So today we're working on building kind of something different, something interesting. Now, I've been building batteries, lithium batteries, for quite a while, and I use these 18650 cells, hot glue them together, spot weld them together, and I make some good packs for electric bikes, electric mopeds, you name it. Batteries are really useful, and since you can put them in a lot of configurations, you can technically build any size battery you want. However, today we're just talking about foam batteries. And this little chip right here, this is a 18650, which is one of these green cells. It's like a huge AA battery that's rechargeable. This little chip converts that to a USB and a micro USB. Let's try to focus on that. So basically you solder those here and here and then plug it into the USB side. Basically, it turns one of these cells into an external battery to charge your phone. Now, we've all seen those before. To get through the day, a lot of people have to buy external power banks that they can use to charge their phone. So today, I'm going to show you basically how I can build my own, how you can build your own, and that you can basically build any size you could think of. And it's not really that hard or very expensive. So let's get into it. So here's a normal iPhone charging cable, a lightning cable, and you can see, as I said, it just plugs in to this chip. So we're going to be testing this by charging an iPhone. But let's take a look at how exactly we're going to do this. These are holders to hold the 18650 cells just in place so that I can weld them together. We're going to connect all of these in parallel. That means that these batteries already have the right voltage, 3.7 volts, to convert to 5 volts to charge a phone. So instead of building a pack where we need to increase the voltage, we just get to keep the same voltage and link all of them together so that we're drawing from all the batteries at the same time. Therefore, it increases the capacity. So technically, you can add hundreds of these batteries and link them all together so that you draw from all of them at the same time, and you're only using, well, basically you can build an infinite amount of capacity. So since these are all lithium, we're going to test and see just how big of a battery we can build. I know I only have maybe 50 or 100 cells left, and you can see my soldering iron is all ready to go, but we're going to solder this to some wires. Then we're going to weld all these together using this spot welder right here, and we'll get going. So I'm sure this looks funny, but this is currently the only size wire like I have ready to go in stock. I believe this is 10 gauge, and this is what I use for electric bike batteries to carry 2,000 watts or 5,000 watts of power. But I'm going to use it for this little battery bank. So let me go ahead and solder these on real quick. Alright, so that's done. I've successfully soldered the positive wire onto this chip. So I know that the positive wire is going to go on one end of the battery, but I don't know how big this battery is going to be yet or how long I'm going to need the negative cable to be. So I'll just have to solder that on later. For now, we'll focus on welding these cells together, putting them together, and seeing how big of a battery I can actually build. So let me go ahead. I might, instead of using this holder, I might just hot glue them together because I typically do that a lot just for bigger packs that I'm used to building. So instead of this thing, I'll go ahead and hot glue some together and we'll go from there. Alright, so as you can see, I just took all these cells and hot glued them together. I'm not going for anything too perfectionist, but it looks pretty great. These are all just glued together. I have like a few hundred of these, and I'm obviously using them for other projects. I could have built this thing, 3 or 4 times higher. That's what people do for something like a power wall or a big electric bike battery. In fact, this is big enough to be used in an electric bike, but that's not what we're using it for. So I'm doing this, let's see, we have 8 cells by 1, 2, 3, 4, 5, 6, 7, 8, 9. So 8 times 9, that is math, 72, I believe. So this is 72 cells, and each of these is roughly 1000 milliamp hours, so 1 amp hour each. So we're looking at a 72,000 milliamp hour pack. And it's only, this is the case off my iPhone 10 that I'm filming with. It's about as tall as a phone. Yeah, so it's literally, imagine that was an iPhone 10, which was actually right here, but it's, about a phone tall and a phone wide. It looks pretty good. So now the next step is to basically, and I have to go get my other roll of this stuff, but I'm going to take this nickel strip, which is highly, highly conductive and weldable, and we're going to weld all these batteries together on both ends. So this is the positive end. We'll weld it on the negative side as well, and then we'll hook up the 2 ends of the entire battery to our little USB adapter. So let's go into that. Alright, so as you can see, I've finally welded this entire battery together. So basically, as I said, the positive and negative terminals of all these batteries are welded together using nickel strips, so it's very conductive. And now all we need to do is solder the wires from the USB adapter to each side of the battery, and then get this thing going and see if it actually charges the phone. Alright, I've finished soldering, and I've actually tested this battery. It works perfectly. So I plugged it into my phone to test it, but instead of that, because I'm using my phone to record, I'm going to show you plugging it into some AirPods. So let me set the camera down. Alright, let's turn the brightness down a bit. So, there's the indicator light. If I take this, which as you can see is plugged in to the battery, and it's charging. And of course this case is already fully charged, but yes, this battery does work. All you really need is this little adapter, and you can see there's even an LED light on there running perfectly, and it looks like you can even recharge the whole thing on the other side. Sorry, I can barely hold this. On the other side of this little like $4 adapter, there is a micro USB slot to recharge this entire battery. So technically this whole 72,000 milliamp hour battery, which was just made from old recycled laptop cells, they can't be more than 30 or 40 bucks worth of recycled cells that I bought here, you can recharge this entire thing. So doing the math, the iPhone 10, which has a pretty big battery compared to some cheaper phones, would run for about 560 hours off of this guy. And I just built this in 1 hour with about 35 bucks worth of materials. So it's definitely a really cool thing to know how to build batteries, especially as batteries become more commonplace. Recycled cells are going to be more common. Batteries in general are going to be cheaper and better as time goes on. So I hope you found this useful, and that's how you can build pretty much any size backup battery for your phone, for a survival situation, for keeping in your car, for just about anywhere. This thing will basically make my iPhone 10 run for 2 or 3 weeks on one charge, and that is pretty amazing. So drop a like if you really like this, comment to let me know what you thought, and you should check out my channel because I post projects like this all the time. So have a great one. Have a great day. Sorry.